September 19, 1944, 8 o'clock hours. Arracourt sector, eastern France. First Lieutenant Merwin Mann of the 37th Tank Battalion stood inside the open turret of his M4A3 Sherman, his gloved hands gripping cold steel as dense morning fog reduced visibility to less than 100 meters. His gunner tracked shadows through the periscope, searching for movement in terrain that dissolved into white silence. Intelligence briefings had been explicit. German Panther tanks were operating in the area. Machines whose 80 mm glassy plate sloped at 55 degrees created an effective resistance exceeding 140 mm of vertical armor. Standard American armor-piercing rounds could not defeat that protection at any meaningful range. Mann believed what every American tanker had learned since Normandy. Survival depended on maneuver, flanking fire, and avoiding direct confrontation. He did not yet realize that inside his ammunition rack sat 6 M93 HVAP rounds, each carrying a tungsten carbide core traveling at 1,036 meters per second, capable of penetrating up to 160 millimeters of armor at 1,000 yards. Within hours, those 6 rounds would overturn not just a tactical disadvantage, but an entire belief system built on German armored superiority. At that moment, American command confidence rested on a fragile assumption. The 76 mm M1 gun, introduced into combat after July 1944, was expected to neutralize German armored threats. The logic behind that belief was grounded in test data. Higher muzzle velocity than the 75 mm M3, improved penetration values, and better long-range performance. Ordnance had assured senior commanders, including General Dwight Eisenhower, that the weapon would defeat any German tank likely to be encountered in France. That assumption collapsed under battlefield conditions. Against Panther frontal armor, the 76 mm firing standard M62 APC rounds could penetrate approximately 109 mm at 1,000 meters at zero obliquity, insufficient against sloped armor exceeding 140 mm effective thickness. Engagement reports showed that even at distances under 100 meters, frontal penetration remained unreliable. The expectation of technological parity had been replaced by the reality of tactical inferiority. On paper, however, the American system appeared overwhelmingly strong. The United States had produced over 49,000 Sherman tanks by 1945, compared to approximately 6,132 Panthers built by Germany. American doctrine integrated armor with artillery, infantry, and air power, supported by a logistical network capable of delivering thousands of tons of supplies daily across hundreds of miles. Tank destroyer units supplemented armored formations, while P-47 Thunderbolt fighter bombers provided close air support capable of striking armored columns with rockets and heavy machine guns. Ammunition stocks included high-explosive, smoke, and armor-piercing rounds calculated for sustained operations. The expectation was clear. Even if individual American tanks were technically inferior, the system as a whole would overwhelm any opposition through scale, coordination, and endurance. Then the contradictions began to accumulate. Reports from Normandy described shells bouncing off German tanks. Panther units appeared in far greater numbers than intelligence had predicted. By June 1944, they represented 38% of German armored strength in the theater. Sherman crews reported engagements where they could not penetrate enemy armor at any range while being destroyed from distances exceeding 2,000 meters. German tactics exploited terrain, positioning Panthers in hull-down positions that exposed only heavily armored turrets while concealing vulnerable hull sections. In the bocage terrain, limited maneuver space prevented American crews from achieving flank shots. At first, these incidents were treated as isolated anomalies. But as similar reports multiplied across units, a pattern emerged that could no longer be ignored. By mid-July 1944, the scale of the problem became undeniable. Field reports flooded headquarters, documenting repeated failures of American guns against German armor. A War Department board convened on July 12 confirmed the reality. Standard American tank weapons could not defeat Panthers frontally. The realization was immediate and systemic. Not dozens of engagements, not hundreds, thousands of combat encounters across Normandy demonstrated the same outcome. German tanks dictated engagement distance, direction, and tempo. American crews adapted by avoiding direct confrontation, calling for artillery or air support instead. effectively surrendering initiative. The battlefield had become a contest of physics, velocity, mass, angle, and the American solution had not yet caught up with the problem. As the situation deteriorated, the operational consequences intensified. Reports showed increasing tank losses and reduced offensive momentum. Crews began conserving ammunition that could not achieve results. German units, despite being outnumbered, maximized their effectiveness through defensive positioning and superior gun range. The psychological effect was severe. American tank crews began referring to the Sherman as the Ronson, implying it ignited easily under fire. While post-war analysis would show this reputation was exaggerated, the belief itself shaped behavior. Crews hesitated, delayed engagements, and relied on external support rather than their own weapons. This hesitation allowed German forces to retain tactical initiative even when outnumbered. The imbalance was clear. American forces possessed overwhelming production capacity, logistics, and combined arms capability. German forces, particularly Panther units, held advantages in armor protection, gun performance, and engagement range. The Panther's 75mm KWK-42 gun could destroy a Sherman at over 2,000 meters, while its frontal armor resisted most American rounds. This created a battlefield dynamic where one side had scale and endurance, while the other held immediate tactical superiority in direct combat. It was not simply a clash of machines, but of industrial systems versus engineering precision. That balance shifted in seconds at Arracourt. As the fog thickened, a Panther appeared at approximately 75 meters in front of man's position. The American gunner fired immediately using HVAP ammunition. The tungsten carbide core struck the Panther's mantlet, a curved cast steel structure approximately 100 millimeters thick, and penetrated instantly, detonating ammunition stored beneath the gun breech. The explosion was catastrophic. The turret lifted slightly before fire engulfed the vehicle. 2 additional Panthers emerged from the fog within moments. Both were destroyed before they could effectively return fire. The engagement lasted seconds, but its implications extended far beyond the battlefield. For the first time, American tank crews had achieved reliable frontal kills against Panthers at combat range. Man understood instantly what higher command had not yet realized. The rules of engagement had changed. The first shock did not remain isolated. As the morning of September 19th unfolded, similar engagements erupted across the Arracourt sector, each reinforcing the same conclusion with brutal clarity. German Panther units, advancing in column through fog without adequate reconnaissance, repeatedly exposed themselves to short-range ambushes. American Sherman crews, now aware that their limited HVAP rounds could penetrate mantlets and turret faces, adjusted instantly. They held fire until distances collapsed below 200 meters, ensuring maximum impact velocity. They coordinated between platoons, designating targets and conserving tungsten core rounds for priority threats. In multiple engagements, Panthers were destroyed within seconds of contact, their crews unable to react in time within the confined visibility. What had begun as a single unexpected success became a pattern of systematic destruction. At first, German commanders interpreted these losses as anomalies. Reports from forward units were confused and contradictory. Some claimed American forces had deployed new heavy tanks. Others suggested British Firefly units equipped with 17-pounder guns were operating alongside American formations. The physical evidence did not match these assumptions. Examination of destroyed Panthers revealed entry holes significantly smaller than expected from full-caliber rounds, indicating subcaliber penetrators. Intelligence officers recovered fragments of tungsten core projectiles and began to understand the reality. The Americans had introduced high-velocity armor-piercing ammunition in sufficient quantities to influence combat outcomes. This realization did not arrive gradually. It arrived through burning wrecks and dead crews, forcing a reassessment under fire. The scale of the shock expanded as the day progressed. German armored units, expecting to exploit superior range and armor, instead encountered a battlefield where those advantages were neutralized at critical moments. Not dozens of tanks lost. Not isolated platoons destroyed. Entire companies began reporting heavy losses before establishing firing positions. Panther crews, trained to rely on frontal protection, now faced an enemy capable of penetrating their most trusted defense. This was not simply a technical adjustment, it was a collapse of confidence. Crews who had advanced aggressively now hesitated. Units slowed their movement, waiting for clearer reconnaissance that never came. Each delay exposed them further to artillery, tank destroyers, and coordinated American fire. The initiative began to shift irreversibly. As the fog lifted toward midday, the battlefield transformed from close-range ambushes into coordinated combined arms combat. American forward observers, positioned behind armored elements, began directing artillery fire onto German approach routes. Time-on-target barrages struck assembly areas, disrupting attempts to reorganize shattered units. M18 Hellcat tank destroyers, equipped with 76mm guns and HVAP ammunition, maneuvered into flanking positions using their superior speed, engaging German armor from unexpected angles. Above them, once visibility improved, P-47 Thunderbolt fighter bombers entered the battle, attacking German columns with rockets and .50 caliber machine gun fire. Each element amplified the effectiveness of the others. German forces, by contrast, advanced without integrated support. Their attacks lacked infantry screening, artillery coordination, and air cover. The result was fragmentation, powerful individual tanks operating in isolation against a fully integrated system. The operational imbalance became increasingly visible in real time. Reports from American units documented the sequence. German armor appears, engages briefly, suffers losses, withdraws, or is destroyed. Each engagement followed similar patterns. Panthers advanced in column formation, a necessity imposed by terrain and limited visibility. American units, already positioned defensively, exploited these formations by targeting lead and rear vehicles, trapping columns in place. Once immobilized, the remaining tanks became static targets for artillery and airstrikes. Losses compounded rapidly. German crews, many of them recently trained replacements with limited combat experience, were unable to adapt under pressure. American crews, veterans of the Normandy campaign, recognized these patterns immediately and exploited them without hesitation. Behind the immediate combat, the deeper cause of German vulnerability lay in production and training realities. The Panzer brigades committed at Arracourt were newly formed units, equipped with factory-fresh Panthers but lacking experienced crews. Many tankers had received only weeks of training before deployment. Their vehicles represented Germany's remaining industrial capability, technically advanced, but delivered without the operational depth required to use them effectively. American forces, by contrast, combined moderately advanced equipment with extensive training, logistical support, and battlefield experience. This contrast meant that even when German tanks were technically superior, they were employed less effectively. The battlefield exposed not just differences in machines, but differences in entire military systems. By the afternoon, the psychological dimension of the battle had become decisive. American crews who had previously avoided direct engagement with Panthers now sought it under favorable conditions. The knowledge that HVAP rounds could penetrate mantlets at ranges up to 1,000 meters changed decision-making at every level. Tank commanders maneuvered more aggressively, seeking firing positions rather than retreating. Gunners aimed deliberately at turret faces and weak points rather than firing opportunistically. Even units without immediate access to HVAP benefited from its existence, knowing that some vehicles in their formation could engage effectively. This shift in confidence translated directly into tactical performance. Units that believe they can win fights act differently from those that believe they cannot. For German crews, the effect was the inverse. The Panther's reputation for invulnerability had been a cornerstone of its tactical employment. Crews were trained to maintain frontal orientation toward the enemy, relying on armor protection while delivering accurate long-range fire. Once that assumption was broken, every engagement became uncertain. The mantlet, previously considered secure, was now a known vulnerability. Survivors of early engagements carried this knowledge back to their units, spreading caution and hesitation. This change was subtle but critical. A tank crew that doubts its armor will hesitate before advancing, delay firing decisions, and avoid exposure. These delays, measured in seconds, determined survival in armored combat. As evening approached on September 19th, the cumulative effect of these changes became undeniable. German attacks had failed to achieve breakthrough. American defensive positions held. More importantly, the underlying dynamics of armored combat in the sector had shifted. The Panther remained a formidable machine, but it was no longer untouchable. The Sherman remained technically inferior in many respects, but it was no longer helpless. The battlefield had moved from a one-sided contest defined by armor and gun performance to a complex engagement shaped by coordination, timing, and selective technological advantage. This was the moment of realization, not declared in headquarters reports, but understood by the men inside the tanks. Lieutenant Mann and others like him recognized that the outcome of future engagements would no longer be predetermined by enemy armor. The advantage had not disappeared, but it had narrowed enough to be overcome. From this point forward, victory would belong to the side that could exploit that narrowing gap faster, more efficiently, and at greater scale. The Americans already possessed that capability. The Germans did not. By September 22nd, the German offensive had lost momentum completely, yet the pressure did not disappear. It intensified under a different form. American forces transitioned from reactive defense to controlled counteraction, exploiting every weakness revealed over the previous 3 days. Reports from forward units showed a consistent escalation. German armored thrusts fragmented before reaching objectives. Command cohesion deteriorated under constant artillery disruption. Inexperienced crews abandoned damaged but reparable vehicles. Communication failures isolated units across the battlefield. What had begun as a concentrated armored strike now dissolved into scattered engagements where individual German tanks fought without coordination, increasingly vulnerable to a system designed to destroy them piece by piece. The core problem lay not in a single failure, but in accumulation. German planners had assumed that 150 tanks, drawn from the 111th and 113th Panzer Brigades, would overwhelm approximately 50 American Shermans through concentrated force and superior technical performance. Instead, those numbers became a liability. Larger formations required coordination, reconnaissance, and communication that simply did not exist at the required level. Columns stretched across narrow roads, visibility remained limited by terrain and weather, and each delay exposed vehicles to artillery and air attack. American units, operating in smaller, coordinated elements, exploited these delays ruthlessly. Every destroyed lead vehicle halted an entire column. Every disrupted advance multiplied losses behind it. The mathematics of scale, expected to favor the Germans, reversed under operational pressure. At the same time, the limitations of HVAP began to reveal themselves in combat conditions. The tungsten carbide core, while highly effective at high velocity, was inherently brittle. At impact velocities below approximately 700 to 760 meters per second, corresponding to longer engagement ranges beyond 1,000 meters, the core could shatter on contact rather than penetrate. Reports from tank crews documented engagements where HVAP rounds struck Panther armor at oblique angles and failed to penetrate, ricocheting or fragmenting instead. This imposed strict tactical constraints. Range estimation, angle of impact, and target selection became critical. Crews learned quickly that HVAP was not a universal solution, but a precision tool. Misuse meant wasted ammunition that could not be replaced. This created a new layer of decision-making under fire. Tank commanders had to evaluate distance, angle, and target priority within seconds. Gunners were trained, often through combat experience rather than formal instruction, to aim specifically at mantlets, turret faces, or side armor. Engagements beyond effective HVAP range required alternative tactics. Maneuver for flank shots, call artillery, or disengage. The battlefield became a dynamic calculation rather than a fixed confrontation. Success depended not on possessing superior equipment, but on using available resources with precision under pressure. Meanwhile, German forces faced a different kind of limitation, one that could not be solved tactically. Their own tungsten core ammunition, Panzergranate 40, had been developed earlier in the war and offered similar penetration improvements. However, by late 1944, tungsten shortages had reduced production to negligible levels. German industry prioritized tungsten for machine tools and aircraft engine components, essential for maintaining broader war production. Tank units received standard ammunition, unchanged since 1942 to 1943. This meant that while American capabilities were improving, German capabilities were stagnating. The technological gap was not wide, but it was widening in only one direction. The contrast extended beyond ammunition into the entire industrial system. The United States produced not only tanks in large numbers, but also the specialized materials required to improve them. Even with tungsten constraints, American industry could allocate sufficient quantities to produce tens of thousands of HVAP rounds by early 1945. Germany, under sustained strategic bombing and resource depletion, could not match this output. Production facilities were disrupted, transportation networks fragmented, and raw material access increasingly limited. Each Panther lost at Arracourt represented not just a tactical loss, but a replacement that might never arrive. By September 25th, the operational picture had shifted decisively. German attacks ceased to function as coordinated offensives and instead became isolated attempts to regain lost ground. American forces, maintaining defensive positions supported by artillery and air power, inflicted losses at a rate that German units could not sustain. Reports indicated that German armored strength in the sector had fallen below operational thresholds required for effective offensive action. Units that had entered battle with dozens of tanks now operated with single-digit numbers of functioning vehicles. The offensive had not just failed, it had consumed the very forces required to continue it. The moment of full realization came not in a single engagement, but through cumulative evidence. German commanders recognized that their assumptions about armored warfare no longer held. Superior armor and firepower could not guarantee success without coordination, logistics, and trained crews. American forces, initially at a disadvantage in direct tank combat, had adapted through a combination of technological innovation, tactical flexibility, and system integration. The introduction of HVAP was one component of that adaptation, but only one. It mattered because it fit into a larger structure that could exploit its advantages. By September 29th, the battle was effectively over. German armored forces in the Arracourt sector had been reduced to a fraction of their original strength. American units held their positions and retained operational capability. The numerical outcome was clear. Approximately 86 German tanks destroyed or disabled against 25 Shermans and 7 tank destroyers lost. The ratio reflected more than tactical success. It reflected the collapse of a system that relied on isolated superiority against an opponent that operated as an integrated whole. What Arracourt demonstrated with absolute clarity was that armored warfare had entered a new phase. Individual vehicle performance remained important, but it was no longer decisive on its own. The outcome depended on how effectively technology, logistics, training, and coordination were combined. HVAP rounds, scarce and imperfect, represented a critical link in that chain. They did not win the battle alone, but they made victory possible by removing a key limitation at the exact moment it mattered most. The consequences of Arracourt did not end on September 29th. They expanded outward, influencing every subsequent engagement between American and German armored forces. Reports circulated rapidly through both commands. American units shared after-action analyses emphasizing precise HVAP use, coordinated fire, and aggressive positioning. German intelligence compiled its own findings, focusing on unexpected penetrations and the growing effectiveness of American tank units. What had occurred in one sector of France began reshaping expectations across the entire Western Front. The battlefield lesson was no longer local, it was systemic. In the weeks that followed, American armor doctrine adjusted in subtle but measurable ways. Tank crews were instructed to treat HVAP as a priority resource, reserved specifically for engagements against Panthers and Tigers. Gunnery training emphasized weak point targeting, mantlets, turret rings, and side armor at favorable angles. Commanders began integrating tank destroyers more deliberately into armored formations, ensuring that units with higher HVAP allocations could respond to enemy breakthroughs. These adjustments did not require new equipment, only a refined understanding of how to use what already existed. The effectiveness of American armored units increased not because they became stronger individually, but because they became more efficient collectively. German forces, by contrast, entered a period of increasing constraint. Replacement tanks continued to arrive from factories, but crews lacked experience. Fuel supplies were inconsistent, and ammunition remained unchanged. The Panther's design, optimized for long-range engagement and frontal durability, required conditions that were increasingly rare. Defensive operations dominated, limiting maneuver and exposing tanks to artillery and air attack. Reports from German units reflected growing frustration. Technical superiority existed on paper, but battlefield conditions prevented it from being fully utilized. Each new engagement reinforced the same conclusion: the environment of war had shifted beyond the parameters the Panther had been designed for. This shift became even more pronounced during the winter battles of late 1944. In the Ardennes, German forces attempted to regain initiative through surprise and concentration of armor. Initial advances achieved temporary success, exploiting weather conditions that grounded Allied aircraft. However, the same systemic weaknesses reappeared under pressure. American units, even when surprised, rapidly reorganized, using artillery, infantry, and limited HVAP supplies to contain German advances. As weather improved, air power returned, targeting supply lines and armored concentrations. German fuel shortages intensified, limiting operational mobility. Tanks that survived combat were often abandoned due to lack of fuel rather than damage. The role of HVAP during these winter battles remained critical but constrained. Units reported exhausting their supply within days of heavy combat. Requests for resupply often went unfulfilled due to logistical disruption caused by German advances and weather conditions. Yet even in its scarcity, HVAP continued to influence outcomes. Crews used it selectively, targeting high-value threats at decisive moments. This presence altered engagement decisions, even when not actively fired. The psychological effect persisted. American crews fought with the knowledge that they possessed a tool capable of defeating enemy armor, while German crews operated under the uncertainty that their protection was no longer absolute. By early 1945, the cumulative impact of these factors became overwhelming. German armored units were no longer capable of sustained offensive operations. Production continued under severe limitations, but losses exceeded replacements. Training standards declined as experienced crews were lost and replaced with minimally trained personnel. Fuel shortages restricted movement, reducing tanks to static defensive roles. Ammunition shortages further limited effectiveness. Each of these constraints compounded the others, creating a cycle of degradation that could not be reversed. American forces, meanwhile, operated under entirely different conditions. Industrial production continued at scale, supplying not only tanks but also ammunition, spare parts, and fuel in quantities that exceeded operational consumption. Logistics networks delivered supplies across hundreds of miles with increasing efficiency. Training programs produced crews with standardized skills, while combat experience refined those skills further. Technological improvements, including HVAP, were integrated into the system without disrupting its function. The result was a force that not only sustained itself, but improved continuously during active operations. The contrast between the two systems reached its peak during the final months of the war. German armored units, once capable of decisive action, were reduced to reactive defense, unable to influence strategic outcomes. American units advanced steadily, maintaining operational tempo regardless of resistance. The battlefield no longer revolved around individual engagements, but around the ability to sustain those engagements over time. In this context, even significant tactical successes by German units had limited impact, as they could not be exploited or sustained. Arracourt had revealed this reality months earlier, in a condensed and visible form. It demonstrated that technological superiority, while valuable, could not compensate for deficiencies in training, coordination, and logistics. It showed that even a limited technological adaptation, such as HVAP ammunition, could shift the balance when integrated into a larger, more effective system. Most importantly, it proved that modern warfare was determined not by individual weapons, but by the interaction of all elements within a military structure. By the time the war in Europe ended in May 1945, these lessons had been confirmed across multiple campaigns. German armored forces had been systematically defeated despite possessing some of the most advanced tanks of the war. American forces, operating with technically inferior but more numerous and better supported equipment, achieved consistent success. HVAP ammunition played a role in this outcome, but only as part of a broader pattern. It was one solution among many, effective because it addressed a specific problem within a system capable of using it properly. The final conclusion emerged clearly from this progression. Warfare had evolved beyond the dominance of individual platforms. Victory depended on the ability to produce, supply, coordinate, and adapt at scale. The events at Arracourt were not an exception. They were an early indication of a larger transformation that defined the outcome of the war itself. The final phase of this transformation unfolded not in a single battle, but across the collapsing front of early 1945, where the cumulative effects of industry, logistics, and adaptation reached decisive scale. German armored units entering combat at this stage operated under conditions fundamentally different from those at Arracourt just months earlier. Reports indicated that many formations fielded fewer than 30 operational tanks, often with incomplete crews, limited fuel reserves, and ammunition stocks that had not changed in composition since 1943. Panthers, once deployed as the backbone of offensive operations, were increasingly used as static defensive weapons, positioned to delay rather than maneuver. The technical advantages that had defined them, armor thickness, gun performance, range, remained intact, but the conditions required to exploit those advantages had disappeared. At the same time, American armored forces entered 1945 with a level of operational maturity that reflected months of continuous adaptation. Tank crews were no longer learning under fire, they were executing refined doctrine. HVAP ammunition, though still limited in quantity, was now fully integrated into tactical planning. Commanders allocated it deliberately, ensuring that units expected to encounter heavy armor retained at least a minimal reserve. Gunnery techniques had evolved to emphasize rapid identification of weak points, coordinated firing, and immediate repositioning after engagement. These refinements did not alter the Sherman's technical limitations, but they maximized its effectiveness within those limits. The escalation of Allied air superiority further accelerated the collapse of German armored effectiveness. By early 1945, Allied aircraft operated with near-total freedom over the battlefield. Fighter bombers conducted continuous reconnaissance and strike missions, targeting not only armored units but also fuel convoys, supply depots, and transportation networks. German attempts to concentrate armor for counterattacks were detected and disrupted before reaching engagement zones. Even when tanks avoided direct air attack, the destruction of supply lines prevented sustained operations. Fuel shortages became critical. Reports documented increasing instances where fully operational Panthers were abandoned due to lack of fuel rather than combat damage. The contrast in logistical capacity reached a level that defined the outcome independently of tactical considerations. American forces maintained continuous supply flows across extended distances, delivering fuel, ammunition, and spare parts at rates exceeding consumption. Replacement tanks arrived faster than losses occurred. Maintenance units restored damaged vehicles rapidly, returning them to service within days. German forces, by contrast, faced a logistical collapse. Rail networks were disrupted, road transport was vulnerable to air attack, and fuel production had been reduced to a fraction of pre-1944 levels. Each lost vehicle represented not just a tactical setback, but a permanent reduction in combat capability. Within this environment, the role of HVAP reached its final form, not as a decisive weapon in isolation, but as a component within an overwhelming system. Engagement reports from early 1945 showed that when HVAP was used correctly, it remained highly effective against Panther mantlets and turret faces at ranges up to 1,000 meters. However, the need for such engagements decreased as other factors dominated. Artillery, airstrikes, and maneuver increasingly determined outcomes before tank versus tank combat occurred. HVAP remained relevant, but it was no longer critical to achieving success. The battlefield had evolved beyond the point where individual engagements defined operational results. The moment of final realization came gradually across German command structures. Senior officers reviewing reports from the front recognized that the war had shifted beyond recovery. Technical superiority in certain weapons systems persisted, but it no longer translated into battlefield success. The inability to replace losses, sustain operations, or adapt production under pressure created a strategic condition that could not be reversed. American forces, by contrast, continued to expand their capabilities, integrating new equipment, improving coordination, and maintaining operational tempo. The gap between the two systems widened continuously until it became insurmountable. By May 8, 1945, the outcome was absolute. German forces surrendered unconditionally. In the Western Theater, armored formations that had once represented the cutting edge of military technology ceased to exist as organized combat units. Thousands of tanks had been destroyed, abandoned, or captured. The Panther, introduced as a decisive weapon in 1943, ended the war as a symbol of unrealized potential, technically advanced, but strategically unsupported. American armored forces, built around a less sophisticated but more reliable and producible platform, achieved sustained success through integration and scale. The final accounting reinforced a conclusion that had been building since Arracourt. German losses across the Western Front reached levels that could not be replaced, while Allied forces maintained continuous reinforcement. The disparity extended beyond tanks to aircraft, artillery, and logistical support. Every element of warfare reflected the same pattern. One side operating at the limits of its capacity, the other operating within abundance. In such conditions, individual engagements, no matter how successful, could not alter the strategic trajectory. The historical conclusion is direct and measurable. The introduction of HVAP ammunition demonstrated that targeted technological adaptation could mitigate specific disadvantages, but it could not replace the broader requirements of modern warfare. Victory depended on the integration of production, logistics, training, and tactical execution. The United States achieved this integration at a scale that Germany could not match. The result was not a sudden collapse, but a progressive imbalance that widened until resistance became impossible. This story reveals a fundamental principle of industrial war. Battles are influenced by weapons, but wars are decided by systems. Armor thickness, gun caliber, and individual performance matter, but only within the context of supply, production, and coordination. The experience of Arracourt, amplified across the final months of the war, showed that even the most advanced machine cannot compensate for a system that cannot sustain it. HVAP did not win the war, but it exposed the reality that had already determined its outcome. The side that can produce, adapt, and sustain at scale will prevail.